There is a debate between scientists and linguists alike about the exact definition of a robot. Some say that every machine that a human can control and move from a distance, while others do not agree with this, and their argument is that these machines, like a car or a controlled plane, from a distance, it cannot be considered a robot because it does not have the ability to think and make decisions on its own. And they give an example that if that machine can act according to a predetermined program by moving away from the barrier of 2 steps back and heading to the right or left and continuing to progress, this makes it possible calling her a real human being. It is clear from this that the basic idea adhered to by those holding this view is that the real robot, according to some people, must possess artificial intelligence and have the ability to distinguish patterns, recognize systems, infer and draw conclusions. The basic science in which robots are made is the science of robotics, and robotics is a science concerned with building automated machines that are used to perform a specific task. It is also known as the intersection of 4 basic sciences: mathematics, mechanical engineering, informatics, and finally science, which means the science or field that the robot serves. There are many types of robots, some of which are used in the industrial sector, which are automatic devices that can be customized and reprogrammed, and move on 3 or more axes. And the vast majority of these robots are used in major industrial companies for the purpose of metal welding, dyeing, ironing, picking and transporting objects and control the quality or validity of the final products, as it is used in the assembly of auto parts in factories. These robots are usually programmed to carry out their tasks in a fast, repetitive and accurate manner. The so-called computer vision was added to these robots during the early years of the first decade of the 21st century, which made them enjoy a kind of independence and flexibility in carrying out the programmed tasks. And that is by understanding and analyzing the images it receives in a special computer installed inside it. There are forms of robots that are capable of moving and driving on their own, including drones and autonomous aircraft with artificial neural networks. Perhaps the most prominent of these types are the 2 robots sent by the International Space Agency in 2004 to the surface of Mars. There are some robots that are able to reassemble themselves semi-independently, such as reducing their size to pass through a narrow tunnel, and these robots contain in their model several links in addition to the central processing unit, signal receptors and its own memory, and these robots are capable of some semi-compliant movements. To contain them on a flexible unit, it does this either by converting the energy of compressed air in cylinders into linear or rotational motions, or by converting electrical energy into kinetic energy. There are other advanced methods that have been devised to move robots, including the digital micromirror device method, which was first announced in 1987, and his idea was based on the installation of several thousand micromirrors in the robot to respond to the image element, to add flexibility more in motion and her reaction. There are also types of robots dedicated to doing housework, teaching children and playing chess. This type of robot is called the social robot and has a high degree of autonomy. It is noted that the term social robot cannot be applied to the tool that humans control from afar, as the social robot must pass 2 main tests to classify it as a gender. Turing's test, a test to see if a robotic system can be called an intelligent system. This test was developed by the British mathematician Alan Turing, 1912 to 1954, and it is a dialogue with the robot. If the laboratory cannot be 100% sure that the answer was a human or robotic answer, then the test is considered successful and the robot is intelligent. Isaac Asimov's test. It is a test that aims to show the extent of the robot's commitment to the so-called laws of robotics, and these laws are: the robot shall not cause any harm to human beings. He must obey the commands of man unless it goes against the first law. He must defend himself unless this contradicts the first and second laws. Robots are rarely designed in the form of a complete human being, and it can be said that a robot is a device or machine that can replace a human in some situations, and its external appearance depends on the task for which it was made. The human body is a highly capable organ system that can perform many functions. The robot can perform special tasks that may cause tediousness to humans, take a very long time, or pose a danger to human life, and then the robot is manufactured to perform limited work. The roots of the modern robot can be traced back to robotic devices invented in the distant past and called autonomous machines. In Thebes, in the era of the ancient Egyptians around 1500 BC, a statue of King Memnon was created that used to make beautiful musical sounds every morning. In Greece, during the 4th century BC, mathematician Archytas invented a robotic pigeon that can fly. In the 3rd century BC, Ctesibius invented many mechanical devices, including an organ-like musical instrument that works with water, in addition to a water clock. The water level was constant, and it worked in the same way as the floating chamber of a modern car mixer.